I'm passing it around so everybody can get a close look at it. It's just a little glass jar. There's a vial in here, in this jar. This is a gallon pickle jar with a rubber top held on there airtight by rubber bands. And in the jar, there's a liquid up to here, and then there's a gas above that. The vial is floating in there, and it has a liquid and a gas in it. And I'm gonna press this and you'll see the vial sink. Raise your hand if you see the vial sink. Okay, and then when I let go, it comes back up. So the problem is, why does the vial sink when the cover is pressed? I drew a diagram over here of the jar and the vial is enlarged a lot so that I can show the detail of it. And this is a gas, this is a liquid, this is a gas, and this is a liquid. Now we want to try to find enough data to answer that question. And who would like to know anything about the focus? Anything at all about the focus that might help to answer that question? What would you like to know, Jeremy?
Does the jar contain any water?
Okay, I'm going to change that slightly, Jeremy. Is the jar liquid? Water? Yes. The jar liquid water. So I can erase that word liquid and write water. That's water. All right, who wants to know about some other part of the focus? Another part. Jake S.
Does the jar contain only water?
That liquid is only water, right? Wyatt?
Does the vial contain any water?
2. Is the vial liquid water? Yes. So I can erase the word liquid and write water here. That's water. All right, who wants to know about another part of the focus? There are 2 parts we don't know yet. Which one, Emily?
What the gas is?
Which one, the jar gas or the vial gas?
Jar gas.
3 is the jar gas blank, 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 blank. What do you think goes in the 3 blanks, Emily? Is the vial gas? What fits? What fits, Shayla?
And
Air. Yes, the vial gas is air. Okay, so I can erase the word gas and put air. All right, now, what's the only thing we don't know about so far, Stevie?
what is the other gas?
The jar gas.
Yeah, what's the jar?
You asked about the vial gas, didn't you? Did
No,
you ask
I
about the
said
jar
jar.
gas? Oh, okay, so now we need to know about the vial gas. Is the vial gas blank, blank, blank? What fits in the blank, Stevie?
Air.
Air. Yes. So that's air. When people first see this, they think that I have some mysterious gases and liquids involved here, because this looks a little mysterious. But it's only water and air. Now, here's a question I often get though from some classes. Is the vial gas helium? Why would anybody ask if the vial gas is helium? Harley?
Because helium floats.
Helium rises, right. So that's a very logical question. But no, that's air. Okay, actually that's all the data we have to gather today. Well, now that you know what those things are, I'm going to press it again. Raise your hand if you see the vial sink. All right. When I release it, it comes back up. Okay. Does anybody want to suggest a hypothesis about why the vial sinks when I press the cover? What do you think, Jeremy?
Because since the glove, glove or whatever it's called, thing, you're pressing on it, and then there's the pressure hits the gas, and then the gas hits the valve, whatever it's called, vial, and then it sinks.
Well, you used a key word. Raise your hand if you think pressure is involved here. Okay, most of you think that pressure is involved, and pressure is involved. Emily?
When you put it down, it kind of sends some of the air probably down into the water, which pushes the valve down to the bottom. When you let go, there's no more pressure.
Okay, now I'm going to ask two people to come up. I'm going to ask Shayla and Chase. Come up here and just kneel down here. I want you to kneel down so you can see the vial. Make sure you can see the vial real well. It's hard to see it in there. You see the vial? Okay, now look for this line between the water and the air in the vial. Can you see that line in there? Okay, I want you to tell me whether that line goes up or down when I say push. Push, push. Can you see it, both see it go up? Okay, that's all you need to do. Thank you for your contribution to science. When I push, the water level goes up. All right. Raise your hand if you can tell me what's happening to the size of that air mass when the water goes up. What's happening to it, Jessica?
It's getting small.
How many think it's getting smaller? It must. No air can get in or out. Did you know you can make air smaller?
Okay, yes.
It's called compressing it. C-O-M-P-R-E-S-S. It comes from a couple of Latin words. Common Latin means together, and so this means to press together. And if you compress a gas, you make it smaller. That is possible for all gases, but it's not possible for liquids or solids. And that's an important fact, very important concept. In fact, that's the universal law that's the subject of this focus today. All gases can be compressed everywhere in the universe. Now, raise your hand if you've ever heard the term compressed air. All right. Who knows what recreational activity uses compressed air? Does anybody know about recreational activity? No, it has to be recreational. Janelle? Scuba divers. Scuba divers use compressed air. Who, besides Janelle, knows what they use the compressed air for? What do they use it for? Jake?
So they can breathe underwater.
They use it to breathe. I'm going to draw. We don't need this anymore. So I'm going to draw a scuba diver's tank. This will be almost life size. The scuba diver's tank is about this size. Raise your hand if you've ever seen a scuba diver's tank. Okay, it looks about like that. And up here, it has at the upper end, it has a nozzle. And then connected to the nozzle, there's a device called a regulator. What does a regulator do? It regulates. Okay, but you'll soon find out what it regulates. Okay, then out of here comes the tube for the air and the mouthpiece for the diver to put in his mouth when he's breathing. Okay. These scuba diver tanks, when they're full, contain compressed air. What does compress mean? If you compress any gas, what do you do to it?
Push together.
What do you do to it if you compress it? What do you do if you compress it, Stevie? You make it smaller. All right, now, If the scuba diver takes his tank, his empty tank, to a filling station, air filling station, they screw a hose on here that comes from a compressor tank. A compressor is a big tank with a motor that pushes air in under pressure. Now, Janelle must know another use for compressed air, besides scuba divers, what?
My dad has a huge one in his garage, and it,
What does he use it for, do you know?
for,
Does anybody know
I don't,
what kind of workman's tools operate off of compressed air? What tools, Jessica?
it's called a compressor, and you like use it for cars and stuff, for their tires.
Well, a compressor is used to fill the tank that you get the air from for your tires. Who knows what kind of workman's tool operates off compressed air? Jeremy?
I don't know what it's called, but it's like a power hammer or something, because my dad has one.
Right.
It's like, yeah.
Have you ever been around a place where they were installing roofing on a roof of a house? And they go along with this tool, it goes click, 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 click.
Right.
That's an
It's a
air compressor
nail gun.
staple gun.
Nail gun.
Well, there,
Nail gun.
compressed air also operates nail guns. But if you've been around where they're installing roofing, you hear this click, 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 click every time a staple is pushed in through a piece of roofing. But you also hear a little put, put, put down below where this motor is driving air into the compressor tank. The motor drives the air into the tank under pressure. And then out of the other end of the tank comes this hose leading to the staple gun. And every time they pull the trigger of the staple gun, a blast of air comes out and drives the staple into the roofing. So there are those two uses. Now let me continue this discussion of the scuba diver's tank though. If the scuba diver's tank is empty, he takes it to an air filling station. They hook up a hose to the nozzle and they put air in under pressure from a pump. Does anybody know what the air pressure is at sea level all around the earth? Have I ever explained that to you, what the air pressure is? I don't think I have. So I'm gonna take a little sidetrack here and remind me to come back to that. If this is the earth, it's 8,000 miles across. Then outside the solid earth is the gaseous earth that we call the atmosphere or air. And it's only 63 miles deep. Well, obviously I haven't drawn this to scale, because if it were drawn to scale, the blue line would be just right outside the black line, barely above it, because the atmosphere is only 63 miles deep. But I'm drawing this larger to illustrate a point. All right, so the air is 63 miles deep. Above that, there's nothing, it's space. All over your skin, there's 15 pounds of air pressure per square inch. 15 pounds per square inch. That's about a square inch right there.
In my arm.
For every, well, all over your body, there's 15 pounds of air pressure pressing on you. That's a lot of weight. This jar weighs about 15 pounds. Well, I couldn't hold that jar out very long without my arm tiring. So there's a lot of pressure pressing against your skin. But you don't notice it because you're born in it and you've lived in it already. But it's 15 pounds per square inch. All right. If you get into a situation where the air pressure is significantly below 15 or significantly above 15, you do notice it and you don't feel very well. Here's why it's 15. If you had a column air, an inch in surface area, that big around, 63 miles deep, would that be a long, narrow column of air?
Yeah.
Column of air that big, 63 miles deep. It weighs 15 pounds down here at the bottom. And it weighs 0 pounds up here at the top.
Whoa.
That's the weight of the air in that column, 15 pounds. A column of air, an inch in diameter, or in its surface area, 63 miles deep, weighs 15 pounds. You may have thought air didn't weigh anything, but it does have weight. Okay, why is it 0 up there? why is the weight of the column 0 up at the top? Why? Well, you're not entirely wrong. It's because, for the same reason that if you put the bathroom scale on the top of your head, it says 0. There's nothing up there, there's nothing above that to weigh anything. It's outer space. Okay, now as you go up in elevation, the pressure gets less. 14, 13, 12, and so forth, until you get up at the top of the layer of atmosphere. There's nothing above that, so it weighs 0. That's why there's 15 pounds of air pressure pressing on your skin. That's the pressure at sea level all over the world, and we're near sea level here. Okay, now, the diver takes the tank into the filling shop, and they put the air in under pressure to compress it. If you apply pressure to air, it makes it smaller or compresses it. So what the compressor does is it forces about as much air as in your gymnasium into that little tank. Well, to get that much air into that little tank, you have to put it in under pressure. And let's say the air pressure is about 150 pounds, 10 times as much as the pressure outside the tank. That's a lot of pressure, and these tanks have to be very strong or they'd burst. If you put 150 pounds of pressure in a tire, it would burst. Most automobile car tires only have 32 pounds of pressure. Okay, then they put the regulator back on and the diver goes diving, and this regulator the purpose of the regulator is to regulate the pressure of the air coming out so that it's only 15 pounds. Why do they want the air coming out of the tank to be only 15 pounds? Can anybody figure that out? Chase?
Because if it's more,
It'll burst your lungs if it's more than that. I mean, if there wasn't a regulator and that air came out with 150 pounds of pressure and you had it in your mouth, it would just burst your lungs. So the regulator keeps it at 15. But this air is under a high pressure. Chase?
so the regulator is kind of like a filter.
In a way. Okay. Well, I guess I can erase this. Now, the students that came up and observed that vial when I pressed on us noticed that the water level went up, which means the air is compressing. That air is getting smaller. When the air gets smaller, what happens to the amount of water in the vial? Can anybody figure that out? What happens to the amount of water in the vial if the air gets smaller? What, Jonathan?
Goes up more?
It gets bigger. The amount of water gets bigger. All right. Well, here's why this happens. When I set this up and stretch that rubber sheeting over the top of the jar, the air pressure was 15 out here, and it was 15 in here, which means it was also 15 here, and here, and here. The pressure everywhere in here always has to be the same. It doesn't have to be the same as the outside, but inside it has to be the same everywhere. Okay, when I press on this cover, I'm in effect making the gallon jar less than a gallon. What does that do to the pressure? Does that increase or decrease the pressure inside the jar when I push on the cover? You know, Stevie? It increases the pressure. So let's say, I'll do this in a different color. Let's say that when I'm pressing on the cover, it goes up to 16. That causes that air to compress, get smaller. That allows more water to go in. Now, before we go any further with this explanation, can anybody now explain why the vial sinks beyond what I've told you? Can anybody figure out why the vial sinks now? You want to try, Janelle?
Because with more water
Makes it more what, Janelle?
dense.
Good. More water makes it more dense. All right, everybody ought to be able to answer this question.